The next topic here we have number base. Number base is also another important topic that you people are supposed to know. A number base, it brings a lot of things into our day and today activities. Like in a number base, it's the ones that will help us in counting. Before we are counting in binary, that is in base 10. That is all the numbers that we have is from 0 to 9. In every mathematics, a number is from 0 to 9. We don't have 10 in a digit. Like when we write 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are the numbers that we have in mathematics. And these 0, 1, 2, 3, all these numbers, what we said, like 10, because the reason why that we say if you take 1 and 0 to give you what? 10. So 10, this is 10, we said minus 1, it will give us 9. And also when we take 11, that is 11, when we say 11 minus 1 plus 1, which is 2, 11 minus 2 is also 9. When we take 13, we say 1 plus 3, we have 4. So 13 minus 4 is also 9. Then when we take 15, also 1 plus 5 is 6. So 15 minus 6 is also 9. So anything in mathematics is a multiple of 9. And if you just take like different numbers, like when we say 56, when you take 56, when you add 5 and 6, it will give us what? 5 and 6, it will give us 11. So 56 minus 11, it will give us 45. And don't forget, 45 is a multiple of what? It's a multiple of 9. So these are the numbers that we have in accounting, 0 to 9. So number base is another aspect of counting, but based on the base. That is, we have base 2, base 3, base 4, base 5, different bases. It depends on how you want to count the base. So now, as we have all these as a base, we have the most common bases that we are using. These are the bases we now to say we have base 2. Base 2 has a number from 1 to 0. Base 2 is only 0 and 1. 0 and 1. That is why we call it binary. Base 2 is what we call as binary. So base 2 has a two numbers, 0 and 1. And this 0 and 1, if you now go to computer or any switch machine, if you look at the switch of any machine or of a phone, you will see they will make something like this as a switch. This is from binary. That is, this is 1 and this is 0. If you press it, you on the machine. If you press it again, you off the machine. So we get it from base 2. So that is why I told you number base play a very vital role in our day-to-day activities. Then after base 2, we have octal. That is base 8. We say it, base 8. We have from 0, 1, 2, 3, 4, 5, 6, and 7. This is base 8, and we call it as octal. This is what we call as octal. And this base 8 octal is the one that they use to provide a very small calculator for the people that you see they are wearing it here for a purpose of marketing. And this is base 8. And also when we look at base 10, base 10 also is very important for us to know. That is from 0, 1 up to 9. This is base 10, and we call it binary. Binary. You see, base 2 we call it binary, base 8 we call it octal, and base 10 we call it as binary. And if you look at duodecimal, that is, when we say duo means 2, decimal tens, that is base 12. So we call it as duodecimal, base 12. And this verse 12, if you want to write the number, we have 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead to write 10, then we write A. 11 we write B. 12 we write C. 13 we write D. That is, here we are talking about base 12. So here we have to stop from 0 to A and B. This A is stand for 10, while B is stand for 11. That is a number base. Of bases. That is from one base to another base. As we know, we have different bases. So if you want to convert a base to another base. So now let's start from how to convert base 10 to another base. When you're given with a problem in base 10, you are asked to convert to another given base. So like here we have, for example, express 94 in base 10 to base 2. Then we have number 2, convert 208 base 10 into A, you have to convert it to binary. B, you have to convert it to base 16. And here we have 3, express 574.235 base 10 to base 8. So now let's start to take the number 1, that is 94. So when you're going to convert base 10 to another base, you must draw a chart. This is the chart. Then here you now to write the number that you need to convert as 94. While here you now to write, since they say in base 2 you have to write 2 here. So now here we have 2 to 94. It now to say 2 to 90, it goes 45 times. 2 to 4, it now goes 2 times. When you combine together, it's 47. So here we write 47, remainder 0. 2 times 47, it will give us 94. Then here we say 2 into 47, it now goes 23 times. 23 times, remainder 1. You now try the remainder here. Then we say 2 into 23, it now goes 11, remainder 1. Also, 2 into 23 is 11, remainder 1. Then here we have 2 into 11, it now goes 5 times, remainder 1. Then we still say 2 into 5, 2 into 5, it goes 2 times, remainder 1. Then 2 into 2, we have 1, then remainder 0. Then here we have 2 into 1, it goes 0, but we try the remainder here, which is 1. So all in all, as we now see, this is the conversion from 94 to from base 10 to base 2. So when you come to take the solution, you now have to take from down, that you started taking the numbers from down to up. So all in all here we now to write 94 verse 10 is equals to, here we have 1, then we have 0, then we have 1, 1, 1, 1, and lastly we have 0. Then we write verse 2. This is how to convert 94 in base 10 to base 2. 8 in base 10, we are going to convert it to a binary, that is base 2. So here we say 2 into 208, we have 104. 2 into 208, it goes 104, but remainder 0. Then here we have 2. 2 into 104, it goes 52. 52, remainder 0. Then here we say 2 into 52, it now goes 26, remainder 0. Then here we have 2. 2 into 26 is 13, also remainder 0. Then here we have 2 into 13, it now goes 6 times, remainder 1. Then 2 into 6 is now goes 3 times, remainder 0. Then 2 into 3, it now goes once, remainder 1. And also 2 into 1 it can, it should be 0. So we say remainder 1. So now here we say 208 verse 10 is equals to, we now to take from here of, we say 1, 1, 0, 1, then we have 0, 0, 0, then we write verse 2, and this is the answer. In verse 10 we are going to convert it to a binary, that is verse 2. So here we say 2 into 208, we have 104. 2 into 208, it goes 104, but remainder 0. Then here we have 2 into 104, it goes 52. 52, remainder 0. Then here we say 2 into 52, it now goes 26, remainder 0. Then here we have 2 into 26 is 13, also remainder 0. Then here we have 2 into 13, it now goes 6 times, remainder 1. Then 2 into 6 is now goes 3 times, remainder 0. Then 2 into 3, it now goes once, remainder 1. And also 2 into 1, it can, it should be 0. So we say remainder 1. So now here we say 208 verse 10 is equals to, we now to take from here of, we say 1, 1, 0, 1, then we have 0, 0, 0, then we write verse 2, and this is the answer. So here we have 208. We're now going to convert it to, as they say, to base 16. That is hexadecimal. 16 hexadecimal. So 16 into 208, it now goes 13 times. Because 13 times 16 is going to give you 208. So here we have 13, then we say remainder 0. And here we have 16. 16 into 13 is 0, remainder what? Remainder 13. Instead of you to write 13 as a remainder, you now to write D. Don't forget, D it stands for 13. A stands for 10, B stands for 6, C stands for 12, D stands for 13. So now the answer here we have 208 verse 10 is equals to D and 0, then we write verse 16. 16. This is the answer. 574.235 in verse 10. Then we have to convert it to base 8. That is octal. As I told you, verse 8 means octal. So now we have to draw the chart. The chart here. First, we have to convert the whole number part. The whole number is 5, 7, and 4. We now have to forget the decimal part first. Then here we have verse 8. Then here we write 8. Then we now have to say 8 into 574. It now goes 71 times. It now goes 71 times, then it will less of 6. Remainder 6, because 71 times 8, it will give you 568. So it will have a remainder of 6. Then here we say 8. 8 into 71 is now goes into 8 times. Then we have remainder of 7. Because 8 times 8 is 64. Then 64 out of 71 we have a remainder of 7. Then here we have 8. 8 into 8 is now goes 1 times the remainder 0. Then here we say 8 into 1 is 0. Then we say 1. Then here that is the whole number part as 574 is equals to 107. This is verse 8. 2, we now to convert the decimal fat after we converted the whole fat. So now the second step, that is step 2, that is we now to convert 0.235 in base 10, we have to convert it to base 8. So now on how to convert a decimal fat after the whole number fat, what you're going to do, we start to take 0.235. We say times the required base that we're going to make the conversion, that is we say times 8. And 0.235 times 8, it will give us 1.88. Then secondly, we continue, we take 0.88, that is the last two decimal from the first one, we still multiply by 8 also. Then also this one, it will give us 7.04. And also we continue to take 0.4, then we also say times 8, where we have 0.32. Then also we take 0.32, then we say also times the recurrence, which is 8, we have 2.56. This is how to take it. It depends on how you want the answers to be. And so now the final answer of this 0.235 base 10 to base 8, you now to take the whole part of the numbers. Here we have 1, we have 7, we have 0, and we have 2. We write it as base 8. So now from here you can see 574.235 base 10 to base 8. This is the whole part. The whole part is now give us 1076, and also this one, the decimal part, is now give us 1702. So what we are going to do, we now to write and say it 574.235 base 10 is equals to, we now start to take the whole part, that is 1076, then we say point, then here we have 1, 7, then we have 0, 2, then we write base 8. This is how to make the conversion of a whole and a decimal part in the word from the numbers.